trigonometric substitutions. I will try to solve a few integrals using a trigonometric substitution. I just list a few expressions, 3 expressions, that when we see them, it's really worth to try trigonometric substitution. Of course, if we see them as a part of the integrand. That means this is expression number 1, square root of a squared minus x squared. Okay. And when you see this expression, it's worth to try the substitution x equals to a sine theta. And because of these trigonometric identities, in our identity 1 minus sine square theta equals to cosine square theta, we can simplify, rewrite an integrand without the square root. The second expression is the square root of a squared plus x squared. Then it's worth to try the trigonometric substitution x equals to a tan theta. Because of the identities 1 plus tan square theta is equal to just secant square theta. Also, we can get rid of the square root. And the third one is square root of x squared minus a squared. Then it's worth to do the substitution x equals to a secant theta. Just because of the identity, trigonometric identity, sine square theta minus 1 equals to tan square theta. Okay, that's me now. I will just solve a few problems. Maybe some of them are a little bit challenged, but let's see how can we apply. I have example number 1 ready for you. And this is an integral of x squared over square root of x squared minus 9. Okay, that's me. We can nicely see expression, a typical expression, which is ready for the trig substitution. I will let x to be 9 sine theta. Oh, not sine, secant. Secant theta, because it's x squared minus quantity. Okay? If this will be 9 minus x squared, then will be sine. Okay, that means I will rewrite my entire integral in terms of theta. I will need dx, derivative of 3 secant theta is 3 secant theta tan theta d theta. And let's put everything in the integral. X squared will give me 9 secant square theta, and then denominator is square root of also 9 secant square theta minus 9, and dx is 3 secant theta tan theta d theta. Okay, I can definitely simplify my square root, my denominator, because that was the point. I can write over there 9, which actually could be factored out, secant square theta minus 1, square root of 9, and square root of secant square theta minus 1 is actually tan square theta. Square root of 9, 3, square root of tan squared is actually just tan. Okay, that's my denominator. Let's copy one more time. 9 secant square theta, 3 secant tangent, and this is just 3 tan theta d theta. Let's simplify 3 and 3, tan and tan. And what's left? 9 secant square times secant is secant cube actually. I can put 9 in front and I have secant cube theta d theta. Okay, that means this integral is a little bit challenged, but let's just try. I believe this is different type. This is type of just the trigonometric integrals, which I think was one section before. Let's try integration by parts. Okay, I will try integration by parts. This means what I see. I see a product of secant square theta times secant. That means I will let u, maybe I can keep that color, just for my integration by parts. U du v dv. I will pick secant theta, and I will pick for dv secant square theta d theta, because it's easy to anti-differentiate. Derivative of secant is secant theta tan theta, but I need more space. Secant theta tan theta d theta, and antiderivative for secant square theta is just tan theta. Nice and easy. That's my integration by parts, and we do remember a formula. It's u times v, okay, and minus an integral of v du. Okay, uv minus an integral of v du. Okay, let's see. Secant theta tan theta, that's uv, minus an integral of secant times tangent. Secant theta times tangent and times another tangent, tangent square. Okay, that's what we have. We do have, let me rewrite this, secant theta tan theta minus, and I have secant times tangent. I don't know if I can solve it through the u substitution, but what I will try to rewrite tangent square as a secant square minus 1. Okay, tangent square is secant square theta minus 1. Then I will distribute secant. Okay, let's see what we're getting. I hope we will get something. Secant theta, tangent theta. And then we do have secant cube again, and minus just secant. Okay, theta. Okay, that's actually I do see secant cube, and what I'm doing, I'm solving the integral of secant cube theta d theta. That's let me create an equation. Integral of secant cube theta d theta. I will copy this secant tangent minus an integral of secant cube theta. Minus and minus, negative and negative, will be positive secant d theta. Negative and negative, positive secant theta d theta. Okay, now I see this integral and I see this one, which is actually my unknown integral. I will call I. That's I equals to secant theta tan theta minus I, that's what I'm looking for, and plus secant integral of secant theta d theta. I can add I to both sides. I will have 2I, two integrals, and then this is secant theta tan theta, and integral of secant. That's another integral. I can give you a formula right away. Integral of secant theta is natural log of secant plus tangent. You may check your textbook for the solution, or you can try on your own. Okay, that's now I, which is my integral secant cube. Okay, that's I have to just divide by 2. That means this will be half of the right hand side. Secant theta tangent theta plus natural log of secant tangent, but 1 times half. Okay, that's my integral of secant cube. Now the only thing is we have to get back to my x expression. Everything must be rewrite in terms of x. This is my answer, and my substitution was x equals to 3. Let's try. X equals to 3 secant theta. I can solve this, secant theta is simply x over 3, which I can replace secant with x over 3. But I also need tangent, and I will use my right triangle. This is triangle, this is theta. The ratio for secant in the triangle is hypotenuse over adjacent, which is x over 3. That's the ratio and that's the secant. If this is x, this is 3, this will be x squared minus 9 square root, based on the Pythagorean theorem. And looking at this, tangent theta is simply opposite over adjacent. Square root of x squared minus 9 over 3. Okay, that means let's just copy this our answer, which this will be 1/2, and then secant times tangent. Secant is x over 3 times tangent square root of x squared minus 9 over 3 plus natural log, and secant is x over 3 and tangent is square root of x squared minus 9 over 3 absolute value, and close the parentheses. This is the final answer of the whole integral. Okay, that's we did really touch not only the trigonometric substitution, we did touch a little bit more problems. Okay, I do have another one for you. Let me write it down. Example number 2. Example number 2 is this one. Integral of 1 over x squared square root 9 x squared plus 4. Okay, that means we can see square root and x squared plus 4, 9x squared. I must say that 9 is not really a good number at the moment, because we really would like to see just 1x squared plus the number. That means I will factor out 9. Okay, I will factor out 9, and this will give me x squared plus 4 over 9. We still have square root. Okay, now 1 x squared, square root of 9 is 3, and square root of x squared plus, and now I see 4 over 9. That means I like this form. Okay, I see the square root x squared plus 4 over 9. That means the good trigonometric substitution will be replacing x with 2 over 3, we can see 4 over 9, and tangent, because everything is positive, tangent theta. Okay, then I need the x. I will copy constant. Derivative of tangent is secant square theta d theta. Let's put everything to that integral. Okay, I will keep the red color actually. Let's try. This is 1. X squared will be 2/3 times 2/3. Let me write this way. Tan square theta. And then we do have 3. And we also have the square root. And this will be 4 over 9 tangent, because that was x. Tangent square theta plus 4 over 9. And dx is 2/3 secant square theta d theta. Okay, I can simplify one of them, and maybe I can also simplify that 3, which I don't know if it's helpful, and for now I can't simplify. That means I do have 2, which we can see is in the denominator. I will put 1/2 in front. I left with secant square theta d theta on the top, and tan square theta, and I still have my square root. Let me work it out with that square root. Okay, over there. That means we can factor out 4 over 9. We will have tangent square theta plus 1. And then square root of 4 over 9 is 2 over 3. And tangent square theta plus 1 is secant square theta. That was the point. Square root of secant square is just secant. That means I can put 2/3 secant theta in the denominator. I use the same color. Okay. That means we can simplify what we can simplify. Secant and secant, and 1/2 dividing by 2/3 will be actually 3 over 4. Oh, I can change my color. 3 over 4, and then we do have secant theta d theta over tangent square theta. Am I right? Secant and tangent square. Okay, that's we end up again with the trigonometric integral. Let's see what we have. We do have the coefficient 3 over 4. I will possibly change this for sine and cosine. Maybe we can see, but I think we can simplify a little bit. That means secant is 1 over cosine theta. Tangent square is sine square theta over cosine square theta. I did write the reciprocal. Oh, and actually we can nicely see that 1 cosine is gone. Good. 3 over 4, and then cosine theta over sine square theta d theta. And now I can nicely see the u substitution. I will let u to be sine theta. du is positive, not negative. We have to be careful if we're integrating or differentiating. Cosine theta d theta, and we can see cosine theta d theta is ready for us. That means the integral in terms of u will be just 1 over u squared, and this is du. Integral of 1 over u squared is just negative 1 over u. That's actually u. Okay, and now let's substitute back. 3/4 times negative 1 over sine theta, which actually I can write as a negative 3 over 4. 1 over sine is cosecant plus the constant of integration. But we have to get back to the x expression. Let's check what was the substitution. Substitution was x equals to 2/3 tan theta. Let me write this. X was 2/3 tan theta, which means tan theta is tangent theta, it's 3x over 2. And I need cosecant. I will build my triangle. Theta, tangent is opposite over adjacent. If this is 3x, this is 2, the hypotenuse will be 9x squared minus plus 4, because Pythagorean theorem. Okay, and I need negative 3/4. Cosecant is just the reciprocal of sine. That means this will be square root of 9x squared plus 4 over 3x. Square root of 9x squared plus 4 over 3x. And that's the final answer. We can see I do have a little bit challenge problems, but this is just additional problems for you to practice. Okay, and let's do one more. Example number 3. And the integral looks like 1 over square root 3 minus 2x minus x squared. Okay, that means I do see the square root. I don't see right away my expression that will tell me what substitution to do. That means I will do one exercise that it's called completing the square, because I really have to see under the square root one quantity squared. That means first of all, I will factor out negative, and I will have x squared plus 2x, because it's better if we have coefficient 1. Okay, we do have 3, and then I will complete the square. X squared plus 2x. In order to complete the square, I need the third quantity, and this will be 1. And since I am adding 1 in my parentheses, I know that I'm actually subtracting 1 because it's negative in front. That means subtracting 1 means that I have to add 1 outside. Then I'm not changing anything. Okay, that's me. Let's see what we have. 3 plus 1 is 4 minus x plus 1 squared. Excellent. Now I can almost see. Maybe just to be a little bit easier, I will let u to be x plus 1. This is linear, du is dx, but I can rewrite the integral in terms of u. Just for you to see nicely the substitution, the trigonometric substitution. Okay, that means the trigonometric substitution is telling me that I will let u to be 2 sine theta. Du is 2 cosine theta d theta. Let's rewrite everything in terms of theta. 4 minus 4 sine square theta, and d theta is 2 cosine theta d theta. And I don't know if you can see, but my denominator is 2 cosine theta. That means everything is just 1 theta. 1 d theta. But I can work it out for you. That means let's look, that's what I did in the previous one. 4, let's factor out, then we will end up with 1 minus sine square theta, still the square root of 4, 1 minus sine square theta is cosine square theta. Square root of 4, 2, square root of cosine square is just cosine. Okay, let me write it down for you. 2 cosine theta, and my denominator, which I work it out on the side, it's also 2 cosine theta. That's the reason that we can nicely simplify, and we have just integral of 1 d theta. Integral of 1 d theta is just theta. Okay, okay, and my theta was let me, do I have to come back? Okay, I have to. Okay, yes, yeah, because now I have to come back through the u substitution. Let's see. My substitution was sine theta. U was 2 sine theta. That means sine theta, it's u over 2, and I need just theta. That means theta will be inverse sine of u over 2. Okay, that's what I was looking for. Sine inverse of u over 2. Now, the u was x plus 1. That means instead of u, I will just put x plus 1 over 2. Okay, excellent. That's my final answer in terms of x. Okay. And I will finish my session. If you have more integrals, please ask me and I can solve it for you. Thank you.